encryption algorithms didn't pass muster by a accreditation board on encryption, and so what they did was they removed it. Just can't understand. But OpenSSL MD5 hashes are great. They are great. All those pictures you see, I have their MD5 hashes in a file, because that way I know when I've updated something and I don't have to compare the contents of the pictures anymore. I can just compare the hashes. And picture, it's a 5 megabyte, running through. It's not insignificant. So MD5 hashes are fantastic. SHA hashes are bigger, but do we care? I don't. So, because an MD5 hash, right here, OpenSSL, MD5, temp.txt, right? I mean, that's a lot of bits. 2 to that, I'm good. As I said, I'd bet a kid on never having an MD5 hash collision. Okay. But would I bet my dog? I don't have a dog. He died. But when he was alive, I wouldn't have bet him.
Is it one of your students is the kid, or is it one of your own children?
No, my children.
Oh, I wouldn't Oh, just a random child.
No. Not even my kid. I got 4 of them. I wouldn't. I trust MD5 on all 4 of those kids, right? Even my favorite. All right. Awk. Awk is a scripting language all on its own. Now, okay, if I'm using awk, why can't I use Python? Well, in theory, awk doesn't change, but in practice, there are different versions of awk. So you kind of have to be sparing with awk. But there are times where you would just like to be able to write a good for loop, right? And a printf. Awk gives you printf. So awk is nice for that reason. Awk does run through every line. So what do I want to do? So here, where's temp.txt? Cat temp.txt. Let's say I just wanted to print out. Let's say I wanted to print out the number of words on every line, right? Or even let's just print out the words in reverse order, right? So I could do that in sed, right? In sed, I could say that says not space, right? That's what that means. Is match anything that's not a space, and then not space. Star 2, 1. Okay, so match 2 sets of not spaces with a space in between them, which I didn't put the space in between them, did I? What did I do? This is terrible. This is not going to work. There we go. Okay. Not space, all not spaces, space, not space, all not spaces. The pattern matching goes maximally. So it tries to match the maximum thing. Now here it's going to, so for here, I'm not quite sure what it's going to do with this. It's probably going to match, I think it's going to match Aiden Malone and then space and then 3. Oh, no, it's not. No, it's not. It's going to flip-flop Aiden Malone because it's not space, space, not space. Okay. So, and then the 2, 1 just says do them in reverse order. Oh, got to give it that dot temp.txt. Okay? Yeah, so Malone Aiden. So that swapped all the names. Okay? Now in awk, I could do that as well. So here, cat temp.txt. I don't know if awk takes the command line or not. Or awk print. It's going to be a little different. Okay? Awk gives you words, and you get to access each word with $, the number. Okay? Which is really convenient, right? So that, now I lost the 3 in Aiden Malone 3 because awk, I didn't print the 3rd word, right? So, or I could say, if I just say print NF, there, that's the number of words on each line, right? And awk gives you printf. That's the nice thing, is it gives you printf so you can do conversions and do things the way you want. There's for syntax, there's while syntax. I mean, awk's a language, but again, don't get too fancy with it, because the fancier you get, the more likely it's not going to port. I hope this isn't boring to anybody. I know I'm like the lecture notes. I haven't gotten through 5 lines of the lecture notes. BC is a calculator. I usually use awk, to be honest with you. I usually use awk as my calculator rather than BC, but BC, I don't even know how you use BC. You read the man page. See, I can't even get out of it. No! Okay, there we go.
I have a question.
Yeah.
I've seen you use calc before.
I wrote calc.
Okay.
It's not hard. This is all calc is. Shell script. So it's good. We can look at it. Okay? So what does calc do? Oh, wow, I got XOR in there. That's nice. So I take my command line. $1 is your first command line argument in your shell. So if I say calc blah, the $1 is blah. Okay? I convert all XORs to carets. I convert all X's to asterisks. That's the important one for me, because if I wanted to do a mathematical expression that involves multiplication, and I have to put in the asterisk, now I got to put it in single quotes, because otherwise the shell's going to try to extract file names from it. So what I do instead is I have the sed command in here, so now I just use X instead of multiplication, and it converts it to a time sign. And then I also get rid of commas, because sometimes when you're cutting and pasting, numbers have commas in them. So I get rid of all of those, set it to the environment variable J, we'll get to that, with the back quote, which is the greatest thing in the world. And then I go ahead, what do I do? Oh, nice, okay, so I do echo, nothing, so awk's just reading one line. I don't even know if I need to do that, because begin says do it at the begin, and then you get this printf, and so I just print it out as a thing, and then this is a wonderful shell script. Right, what this does, so here, awk, I'm putting my awk program inside single quotes, right? And then here what I do is I stop the single quote, and then in double quotes I put in my expression, so that's actually, that's pulling out to the shell and expanding J, and then I go back into single quotes and finish my awk script. So that's what calc is. You can steal it. It's on the lab machines. Just bin calc. And it's super useful, right? So, calc 5 times 4, it does that, and I didn't have to do anything too exciting. And evidently I have XOR. Boy, that's not right. Oh no, how sad. I don't do research in Galois fields anymore. It's so sad. GF mult? How about that? 548? Oh, that still works. Okay. We'll get to Galois fields. You're going to love it. You're going to hate it. I love it. Absolutely love it. Okay, Ed. Anyone used Ed? Line editor. Precursor to Vim. Vim actually stood for visual version of Ed. Ed is awesome. Right? It doesn't even give you a prompt. Now you can make it so it gives you a prompt. If you give Ed something it doesn't know, it's just like question mark. Right? But you get those Vim commands, right? All those Vim breakouts are in Ed. Right? So that's it. 3S XB Fred. Right? Now I've just, in line 3, I just changed that EXP to Fred. Right? So it gives you a it's a line editor, right? And what I did, I know students who have done this because they wanted to, because they're like, well, Dr. Plank did it, that sounds like fun, but don't do this during the semester. When I went and worked at Xerox, this was at Xerox, that's right when I was using Emacs, because that's what we used. And that was right when the GNU Foundation took over and changed every single thing about Emacs. Everything. I couldn't use it. It was unusable. Like Emacs, it used to be backspace, went back a space. And then they changed it so that backspace brought up a help menu. I mean, things like that, you just couldn't use it. I was so freaking mad that I went to Ed. I'm like, I'm using a line editor. Never changes. I can use it on a teletype. And so for 2 weeks I used Ed, and then I couldn't do it anymore because it's just too hard. But man, my Vim skills. Then when I went to VI, my skills were just out off the charts because you got to you got to conserve stuff when you're working on a line editor. A line editor is also good. So ed is also good when you got a super slow connection, right? Do people? I have. Do you have times where your connection is so slow that like you type VI and then it takes forever for the window to cup, and then you type anyway, and now that becomes VI commands, right? And you don't know what you've done. Ed, when that happens, go to ed, because now you know what your commands are doing, right? And it's, it's not using many window commands. We should put you all on I'm so old, on a 300 baud modem. Yes, I've used a 300 baud modem before, and every keystroke matters. Okay, and ed, I'll give you a little more ed. There's more ed in the lecture notes. Ed, you can script with ed too. It's harder, so you typically don't. Like if you can use sed, grep, awk, those are great. If you have to default to ed, and of course jgraph, if you could compile it. Okay. All right, and then I go through that example. Okay, all right, so now, God, this has gone on forever. I'm sorry it's gone on forever, but I do feel like it's useful for you. So that's good. Okay, you're nodding. Good. When I taught in COVID, I tell you that, when I taught in COVID, man, someone just ripped me a new asshole on the JGraph lecture. I mean, just boring, blah, blah, blah. Insulting. You make me come to class and have me do that. Okay, you can combine commands in two ways, well, more than two ways. One is with a semicolon. Okay, so a semicolon will combine your commands. So what here? Echo hi, echo there, right? That just had those two commands. Sometimes not overly useful. However, there's also putting something in a parentheses. That gives you a subshell that'll execute these commands in. So now if I say echo hi and echo there, right, now I can pipe that to word count, and it'll combine the two, and then allow you to, and then it allows you to basically run that in a subshell, and then that subshell, now you can pull out, and now you can do another shell command. You need to be careful about environment variables when you do this, because if you set an environment variable in the subshell, it's not going to come back to your supershell. Okay. Oh, this is a nice one. So here, files, programs, timing. Why do I have these long file names? All right, so I have in this files directory, I have two program timings. This is something that I end up doing at times. Okay, so here, grep dot, I'm teaching you everything. Files, PR star. Okay, what's that going to do? Grep dot just greps for any character. So what that's going to do now is it's going to basically cat the two files when it'll put the file names in front of them, because when I give grep more than one file name, it puts the file name in front. So here are my two files. I think they're 10 lines each, and they have timings in them. And now let us suppose what I want to do, maybe for JGraph reasons, I want to print, here, let's just cat here instead, files, program 1, and then program 2. Okay, let's say I want to print out the first line of each, and then the second line of each, and then the third line of each. It's kind of a pain to do that, right? Okay. So here's something you can do to do that. All right, so first, what I'm going to do is I'll use sed, and I'll say, I don't even need, no, yeah, I do. I'm going to dot A, I'll do this one, program timings 1. Okay, so that's putting an A in front of each of those, and then with program 2, I'll put a B. Okay, and now what I'll do is I will, inside a subshell, I'll take that, pipe that to cat-n. Okay, and then I'll do this one, pipe that to cat-n. Okay. All right. So now what happens when I sort them? When I sort them, I'm going to get the first lines and the second lines and the third line. So pipe that to sort dash n. Okay? And now what I can do is I can pipe that to awk and say print 3, right? Because that's going to print. So now that's going to isolate the lines, right? Now if I say print f, let's say s, no. When you do print f in awk, it doesn't put the new line in. Okay? So now I got them all shoved together. So I can do that, and then I can say if 2 equals b, print nothing. Oh man, oh, I needed a space. So print, there we go. There we go. See how that works? And it's fun, right? It's fun. It's like solving a puzzle, right? Now you can't tell your friends about it because they'll think you're a loser, right? But we can tell each other, right? And then when you see your grad student doing it, your heart fills with joy.
The first said
Oh,
you're doing,
okay, sorry, go ahead. No. Okay, you then Calvin.
with the first said you're doing s slash, so that's substitute. What's the caret doing?
Okay, the caret is beginning of line.
Okay.
So here are the sed commands. Where are they? There we are. There's the sed command. So what that's saying is beginning of the line, substitute for the beginning of line an A and a space. So that's what puts the A here.
Yeah, and then you do the same thing.
B. And then we pipe into cat-n so you get a number you can sort with. So it'll sort the ones before 1 A's and 1 B, 2 A, 2 B. All right, so there's my sort command, and then I use the awk command to basically extract it and format it. So it's fun. Calvin.
I can't remember from your last question notes, but for the timings, when you're running a program over a long range of
Mm-hmm.
and values,
Yeah.
What's the best approach for like a shell script to do that rather than having it?
So time sucks. Time sucks beyond belief. Right? So here, what command will I time? Here, wc temp.text. Now we time it. All right? Every shell time is internal to the shell, so every shell has a different syntax for timing. C shell -c that. Thanks, C shell. Right? Worse yet, guess where it's printing it? Standard error.
Oh.
And you can't extract it, right? If you say, like, time wc.temp, so here, grep real. Oh, damn it. That's why I hate time, right? It's timing the grep real, right? It's timing the whole thing, and it's not doing grep real. Right, so it's timing wc temp.text grep real. So instead, I need to do something. So sh-c is your friend with time, because now I can do that. sh.c says execute that string in its own subshell. So now I know the grep real is going to go do the output of the shell. Okay? Or not, motherfucker. Oh, I hate time. It's printing standard out. My grep is grepping standard out, and it's going to standard error. So the grep isn't doing what I want. 2 and 1. Yay! Okay. And this doesn't work on the C shell. That's a bourne shell, which says take file descriptor 2. Let me specify its output. You can do this to a file if you want it, or to dev null if you want to get rid of it. Okay. And then the and 1 says put this on the file descriptor 1. So that's why that goes to standard out, and now I can grep it. Right. See, we can also have fun. Here. JGraph. Make 2 dev null. Hey, look, no compilation errors or warnings. All right, so I took standard out and shoved it to dev null. Okay. You're learning pearls. Anyone have any idea where that reference comes from? Did anyone ever see the movie Scent of a Woman? Watch Scent of a Woman. It's one of Al Pacino's greatest movies. And he is fantastic. Sorry. Go ahead.
That big set command you just had with the print and the F statement, what was that if statement accomplished?
Oh, okay. Here, we'll go back. This one.
Yes.
So when I'm so each line I'm printing out the third word. Okay. So without this if statement, okay, it's going to print out the third word, which is going to be the timing, but I don't get a new line. So what I want to say is after I print the ones from program 2, I want to print a new line. And so how do I identify that? Well, I put a B in front of the program 2s. So the second word is going to be a B. So that's why I have that there, which says if the second word is B, then print a new line. So
So, print automatically puts new.
yeah, printf doesn't, but print does.
If you wanted, you could do printf and then it's like \n.
Yeah. Yep. That one.
So going back to the timings, say if you have an algorithm that knows like O1 squared,
Okay.
and you want to actually like do the trials over a range of n, plot that.
Mhm.
What's the best approach to do that?
Either use time, and now you've seen my trick on how you get it. But if you do that, I would specify you're doing it in the shell. Like shell the command. So in case you're not in a shell, if you have like T shell or one of the other ones, it'll work as timing is specific. And then do it that way, unless your program is fast, because when you time it this way, you're timing the time it takes to launch the program, right? So if your program's fast, now you're timing loading times. So when things are fast, you really got to put the get time of day calls inside your C programs and then calculate that. And you need to isolate, because I/O is slow. You're not taking 360. I don't know if I did this in 3. I did it in 202. Half of you didn't have me in 202. In 202, I do this beautiful thing where I'm teaching you priority queues. Now, do we recall priority queues? There's only one time when a priority queue is actually better than using a map. I mean, they're always faster, but big O-wise. Do we recall the one place where using a priority queue is actually superior to using a map? Nope. It's will. I can just say nope and not be nice. No! Sorry.
I'm trying to find one max.
That's insertion sort. I do like that you're grasping. When you create a priority queue from a vector, okay, you create it from the vector by starting at by treating it like it's a binary heap, and then doing percolate down at successive higher levels. And that creates your heap, and that act is actually linear. It's fantastic. Okay? So that's, is your interviewer going to ask you that? No, they're stupid. But that's what differentiates. And then in my 202 lecture notes on priority queues, there we go, 202. Hello, lecture notes. Priority queues, they're somewhere. There they are. Right, remember, binary heap. So the way you create a priority queue, we'll get there. A lot of code. Yeah, here it is. Right, you start with the unordered vector here, but it's logically ordered in like a tree. They're not pointers, right? This is just our vectors, 0, 1, 2, 3, 4, 5, 6, 7, 8. And because it's a complete binary tree, you always know how to get everything. And then to create it, you call percolate down, percolate down, percolate down, percolate down. Each percolate down call is going to be log of the height of the tree. And if you sum them up, it's linear. It's like magic. Okay? So whereas if this were a map, you'd be doing n log n to create this. Okay. And then, see, I have some math. And then this was the first time I tried to show this. So I implemented them both, time it, and I got that. Now this graph is unpublishable for 2 reasons, right? One, it's squiggly. So how do we get rid of the squiggly? If you created a graph like this, and you came to me and said, I want to publish this graph, I'm going to say, no, you can't. What? Because it's squiggly. How do we make it non-squiggly? Yeah. More times. A lot more times. 1,000 times. That gets rid of the squiggles. Okay? But it's also not showing what I want it to show. Right? I mean, not only It's terrible, right? I can't draw the conclusions I want to draw. You can't stop here. I've probably beat on this one before. You can't stop here. You have to explore why. Now, as it turns out, what I was doing was I was just timing the program like I was advocating to Calvin, using time. Well, what am I timing? I'm timing the launch time of the program and the time it creates. I was reading these from a file. The time it creates for me to read the numbers from a file was dominating everything. So I'm not showing what I want to show. So instead, I write a program, it calculates the vectors as random numbers inside, then it starts timing with get time of day. Run my algorithm, call get time of day, subtract. And then do that multiple times, right? So then I get this. And if you look at number of elements, right? 100,000 is taken a half a second. Should have been a clue, right? My machine's running at 3 gigahertz. Whereas here, 100,000 elements is taken that, right? So, and then you could definitely show that the vector constructor is better. What's going on here? No idea. Cache effects. That's what's going on here. That's what you say when you don't know. You say cache effects. Okay, I'm never getting through this lecture. May, shall. All right. So what did I do? Okay, I've done file expansion. Environment variables I've kind of done. We're not even going to clicker today. Did you want a clicker today? You don't care. I'll get it for next time. I actually wrote it this morning because it's not on blue filters. What am I doing? Oh, environment variables. So you can set an environment variable, like I equals 1, and then I can say echo I. Now, if I say, I'm not sure if this is going to work. Echo I. Shit. Oh, there we go. Oh, no, that's not going to work either. Sorry. Okay. Yes?
Is I just going to equal 1 forever until you reset it?
Yes.
I hate that.
No, but when I exit the shell, it's not.
Oh, okay.
Yeah, so it's only specific to this shell. And this is what I'm showing here, is if I call a subshell, here, I'll do it here, shell, echo I. It doesn't exist in the subshell, okay? And that's what I was showing here as well, okay? Is that if I execute the program echo I in the shell, it gives me nothing. Now, if I say export I, what that says is now it's part of my environment, and it's going to be inherited by every sub-process. Your environment, you can say print end. These are all of your environment variables that will be inherited from one thing to another. Right? And I set most of these in my shell, in my .bash RC file. Okay, well, you had a question?
If you kill the shell, will it invite export iron?
No, done. It's gone. Yeah.
Is it going to affect any any programs that you have that use the variable I when you run them in the shell?
Yes, if you export it and then you execute those programs from that shell, they will have this environment variable. It's in your programs, in your C++ programs, you call getEnv. GetEnv, if I say getEnv pick 7, it will return to me this string. And in fact, those of you who have taken CS360, the execve system call takes program name, argv array, and then envp array, and your envp array is in fact this. Okay? But when if you just call execv, you don't specify it and it inherits it. Okay. So and you set these in your bash RC. I set these in my bash RC file, right? So bash RC, right? I'll have, Xmas equals that, export Xmas, and now that's my, that's the directory of all my family's Christmas lists, which sucks because they all use frickin' Google Drive, right? No one just uses Vim. They don't know what I bet. So my family, what do I got? I got 6. I always got 6. I got 4 kids and 2 spouses. That they're just all my children. If I asked each one of them what is a file, I think 2 of them wouldn't know. and they're in their 30s. Three wouldn't know, and they're in their 30s. I have no idea. Absolutely no idea.
What's the right answer again?
What's a file? It's a collection hey, I'm teaching this in 360 today. Right? Your file's composed of 3 parts. Now, I wouldn't expect this answer. But all I'd expect from them, it's something that's on my disk that I can reference, right? I mean, that would be fine. That'd be good. You know, your file's composed of 3 parts, foreshadowing or post. Did they even take Meteor 360? Okay, just a few old ones. All right, what's a file? You got the bytes on disk. Those are the blocks. You've got the inode, which contains the metadata for the file, like who owns it, how many bytes are it, where is it, and then you have the directory listing, which associates a name to the inode. That's what a file is. Never getting through anything. Okay, there are some environment variables that are just there. So pwd is always there. If I change the directory, pwd will change with me. Okay. I don't like using it because I don't trust it. So it must be that I got hit with a shell where it didn't work. But I'm older than you all. When I had to work on an Intel multi-computer, Intel wrote the compiler and the shell. Nothing worked. It was terrible. Intel can't write software. Home is a good one, though. I can trust home, right? Home's my home directory, so that's a nice one. You use that often in your shell scripts. User, it's me. On my Mac, I'm Plank. Why? I don't know. I'm JPlank on the other machines. What is the other one? Home. Oh, and path. Do we know about path? Right. Path. These are all the directories it looks through to get your file, to get executables in that order. Okay. And you can set that in your Bash RC, or if you're Conda, you set it like 15 times because Python's awful. Okay. Back quote. Class is over 35, right? Okay. And I didn't bring lunch today. Lunch is sitting on the kitchen table right now. Sad. All right, back quote. You saw it in the things. What back quote allows you to do is run a command and then take standard out, smashes it into one line with spaces, and then you can set it as an environment variable. Right? So I can say b equals echo hi, right? Echo b hi. Or b equals wc temp.text, echo b. Okay? So if I said wc temp.text, you notice it takes the formatting out. So it takes the formatting out, puts everything in with single space, and then if it's multiple lines, it'll smash them all down. So b equals cat temp.text, echo b, right? There they all are, all in one line. It's like the most important part of the shell. Now you do need to remember that running processes is slow, right? So if you write a shell script that's going to take 10,000 files and execute a command on them, that's going to take time. Now sometimes that's fine because you're just going to do it once and you just want it done. But if you're putting it in something that you're going to run often, you just got to remember that may well happen. So back quote is great. And back quote you can do, I could do b equals, this wouldn't make any sense, right? But echo hi, echo there, right? Okay, it'll do the subshell. So you can put big things into that and get them. Okay, arithmetic. B equals 1, echo, no. Great syntax, whoever designed this one. Okay, that lets you do arithmetic. $, double left paren, put your expression. Oh, by the way, integers, no floating point allowed. In some respects, that says God. Okay, and then that allows you to do that. So if you want to increment b, right, you say b equals b plus 1. What'd I do wrong? Oh, maybe it's just the command itself. There we go. That didn't work. Whatever, it's in the lecture notes. Why isn't that working? I don't know. I don't have time to think about it. Oh, okay. Loops. You get if, the way if works. So if looks at the return value of your command. So you know how when your C programs you say exit 0 or return 0? That's for if. Okay. So I think I have a program. There we go. I got a program called exit code, which all it does is it reads a value and then it returns it from the program. Okay? So if I say echo 0 into, is that one? It is coming from standard in. Okay. So if I say echo 0 into bin exit code, right, it's not going to print anything, but it's going to return 0. Now if I put this in an if statement, if I say if that, then print true, else print, oh shit, it should be echo, damn it, then echo true, else echo false, whatever, we'll misspell it, right? You'll note that 0 executes to true. So when you say exit 0, that becomes true. If you say exit anything else, that becomes false. Okay? So that's how you can test the return values of your programs if that's something you want to do. Now there's a program called test. So if I say test,
Is the FI end?
yeah, it is. So you've got if, else, and then phi ends it, and if you want to do else if, it's elif, E-L-I-F is your elif, if you want to do a bunch of things. Okay. What was I talking about now? I've forgotten it. It's okay. You're all good.
Test command.
Oh, the test command. So the test command, hell, I don't even know how it works. With test, the test command, 1 equals 1? Oh, it just returns. I have no idea what it returns. So test allows you to do Boolean expressions, and it returns the exit code. But the shorthand in the shell is you can do this in square brackets. So if 1 equals 1, then echo true. I'll just phi that because it will echo true, right? Now, so here I could put B in here now. And that's there. And then that's string equality, although with numbers it typically works. If you want numerical equality, you can do -EQ. You get Booleans, you can do ORs. So you got EQ, you have -GE for greater than or equal to, right? All of those things, you can mix things with Booleans. Again, keep them simple. Okay, but that's very useful. There's while. So now I can say, while. I don't know how to increment a number.
Use the double parentheses, plus.
Does that work? Oh, I bet that's not Bourne Shell. I bet that's newfangled kid stuff. Grep while. Scripts. There we go. Okay. Oh, I don't like either of those. All right. So while, it's just while. You put the Boolean expression in the while, and you say while do. Here, we'll take a look at read. I had 3 minutes left, and I was going to get through all of this lecture today, but it is useful. Read is line based. If I say read, it'll just read in whatever line and stuff it into A. And if I'm at EOF, then it'll return 1. Returns 0 normally. So what this does is this just is how you can read lines if you ever want to do it. I don't do it much, but when I need the functionality, when you see me like putting stuff up on the screen incrementally, I'm doing read just so I can get when I'm hitting return. So scripts, read, right? So I'm just reading it, Fred. Okay. And then when I control D, it exits because the read now, it exits the while. But you can also do tests with this. God, I can't believe. Here, I've got 3 minutes. Junk.shell. I equals 0 while I is less than 10, do, echo I equals, yeah, that's how you do it. I don't know what I had wrong. Yeah, right. So that's a simple way of doing your for stuff. Now, for loops. For loops work in a couple ways. One is you can say for I in A, B, C, D, E, F, G. Do, echo I. That's a for loop that's now going to run through I, setting I to A, B, C, D, E, F, G. Oop. Okay. So this is often nice, right? If I could say for I in \ls, right? And now it's going to do this for every file in my current directory. And this is how I do grading. My grade scripts are always, right? I'll have a, now no FERPA violations today. You saw that roster file, right? I'll go through every first word in that roster file. I use set or awk to grab that out, and then I keep your exams in one set of files, I'll keep your grades in another set of files, and I'll keep comments in another set of files, and then I can just run those scripts to generate all the stuff. All right, it's nice that way. All right. 1 minute. Would I let you go? For I do, echo I. So if you say just that, it grabs them from the command line, right? Which can also be nice. Still got 1 minute. Echo $. That's the number of arguments on the command line. Okay? If I want to grab things from the command line, I use 1, 2. Those are the things that get me the command line arguments. Okay? And then lastly, and then I'll let you go because it is time and I have to eat my crackers for lunch. If you say shift will basically shift your command lines by 1, so that it eats command line argument 1 and then shifts all the ones over. So 2 becomes 1, 3 becomes 2, etc. Sometimes useful. And then you can say set. If I say set A, B, C, D, that actually puts that on the command line. So that now you can use it. All right, bye.